let's move on. I came here. It's more quiet and I can talk freely. So I hope you can see me well. So let's go. After calculating these, the current data, I mean here the current level of Six Sigma and the current level of DPMO here. Okay, so we have defect rate 148. Defect percentage 3.1, the performance 69.9 or 96.9, and the DPMO 31,282. Now we need to define the next step, which is the target. What are the number of defects we need to reduce, okay, or we need to eliminate? What are the percentage level of the defects we need to eliminate, and what is the DPMO we need to also eliminate? So here we create another table here, and we said the project target. And in the project target, we said, okay, we have 148. Okay, let's decide we need to reduce it to 71 to 80. And here we depend on the discussion with the team, with the top management, and with the customer as well. Depend on the project. We define and decide the defect quantity, and we decide also the percentage of the defect from 3% to 1.5, from 96 to 98 efficiency and the performance. And so the DPMO will reduce from 31,000 to 15,000. What I need to say here, it's a matter of calculation. Yani, I mean here in this Excel sheet, I will give it to you. I put here the percentage of defect you need to reduce. And based on that 1.5, you decided, you and your team, or you and the customer, or you and the top management, or all of those, to decide the percentage. And based on that, all the other factors will be calculated. I designed the Excel sheet based on that. So the output here is the DPMO, the new DPMO, the objective we need to reach. You will take this amount, you will put it here as target. And I think you know the step. You will make interpolation with the DPMO lower and DPMO upper from this table reference, okay? Why we do that? Because we need to decide the new Six Sigma we need to reach, okay? So the target here is to reach 3.67, okay? And how did you calculate that? You have here 15,000. So you will take this 15,000 and come here to this reference table, and you will look for 15,000 as DPMO. You will find it here, somewhere in between here. And since you don't have clear number for DPMO, your target 15,000, you will make interpolation between these four numbers to get the real Six Sigma. And also, you don't need to make anything, just you need to, I'm sorry. What you need to do is to take these two numbers and put it here in that table here, and the relative or the relative sigma level, you will put it here as well, and then you will have the target sigma level. Fine. So our target sigma level, we need to finish this project reaching sigma level 3.6. Okay, so we will make this table here as is and to be. So we have here defected quantity 148. We need to reach 71. The percentage 3.1, we need to reduce it to 1.5. The performance from 69.9, 96.9 to 98.5, and the DPMO from 31 to 15,000. So we need to enhance, we need to increase the sigma level from 3.36 to 3.67. And here's the question. Someone will say, what are you doing? You need to make a big project and make actions and improvement just to increase the sigma level from 3.36 to 3.67. What is that? and here's the point, in the academic introduction, or when you study something, I mean here you can say I will use Six Sigma from 4 to 5, like that, or from 4 to 6. This is optimistic. But in the practical, you can create a project just to raise Six Sigma a certain portion inside the same level of Sigma, but you take it step by step. Maybe in the next project, you will raise from 3.67 to 3.9 or 4.1 and so on, okay? So automatically you will have these defect rate will be raised from the, the defect should be reduced from the current to the target, and Six Sigma level should be increased from the current to the target. All of that, we are working in the measure step, and measure step, we just collect data and prepare this data and understand where are we. Then we move to the next process, which is analyze. And in analyze, we take this collected data and move to the vital factors, or the vital few factors, or the root causes that we need to attack, okay, to achieve our target. Fine. I added here some introduction for you to explain to you what is the objective of this process and what are the tools and techniques we may use to achieve our target. And here is the second point. Some people ask me, do we need to apply all the Six Sigma tools in order to achieve the target? The answer is no. You don't need to apply all the tools. You just need to apply one or two tools to achieve the objective of your processes. For example, you may use process mapping, brainstorming, cause and effect diagram, design of experiments, hypothesis testing, and some tools. Fine. Here, to find the root cause, we need, number one, we need to draw the process map. We need to draw the flow chart of your processes to achieve these paper cups, so that we can analyze and we can find the root cause. Okay. So we write here again the steps of your process, or of your industry, or of your introduction or production to have this product. And to draw the flow chart or the process map, you need to understand some elements. This shape, it means you have either input or output. This shape, it means you have to decide something, and here used for the process. Okay. Okay. Quickly, let's draw this process for the process map. Actually, I didn't complete it 100%, but I will give it to you. You can change it or move it to have your accurate process map for your industry. So here you check and accept the paper reel, which is here in the first process. If it's accepted, you will move to the next step, which is printing this paper reel to print the logo and the shape of the coffee or something like that. If it's not accepted, it will come back again to the checking process, and so on. You will make printing. The printing is okay. If it's okay, you will move to the next process. If it's not okay, you will go back. As I told you, I didn't complete it 100%, so maybe this is for another process. Anyhow, just I need to give you the idea. Okay, just I wrote here to myself, please continue or complete it. So okay, just I hope you got the idea. And then you will move to next step, which is the process of understanding the root cause of the factors affecting the defect percentage. And to understand this and to use it, we move with something called Ishikawa diagram, or cause and effect, or fishbowl. And simply here, it's like this. It's like the fish, actually. And you do it by, let me put it in that way to be easy. You write here the defects, okay, or the result of the problem You write here the result of the problem, and then you start analyzing this problem by writing the root causes that may impact or may result or may cause this effect, okay? And to make it easily and to standardize these fishbone or Ishikawa or cause and effect diagram, we write here 5M plus 1E. Yeah, 5M means like maybe the problem due to machinery, maybe the problem due to the manpower, maybe due to method, material, measurement, or environment. So you write here the probabilities, different probabilities to have this problem, and to memorize them, just 5M plus 1E. 5M here plus 1E, which is environment. You put it in this diagram, and then you say, maybe the problem of this rolling accuracy due to the material. What are the breakdown? Let's break down this problem. Okay, so due to material, maybe the paper content itself, maybe the heel quality, maybe the thickness of the paper, you know, all of this due to material. What else? Maybe method, maybe the operation procedure, maybe the working policies, maybe the technologies that uses to apply this work, maybe due to the environment, a lot of humidity and the air or pollutant air, and so on. And I mean, all of these you are doing through brainstorming, through meetings. And based on that, you meet with your team after considering all the possibilities. It was found that some stages and operation, blah, blah, blah. This, I mean, you know, as if you have a meeting, and the result of this meeting will lead to some root causes. So you will say the root causes due to one of those elements. So you got it? So you collect data, you find the main issue that has the majority of the percentage of the defects, and you put it here to analyze the root causes, and you take the vital, the important, the most affected items as root causes, and you take it here as root causes. So maybe you have a problem due to the calibration of the machine, labor's qualification, and labor training. Okay, so now you got the root causes, and of course in your real project, and after making this fishbone diagram, you can use and you can get the main root causes. Okay, in some other meetings, you can make voting, you can make poll. Okay, so you need to reach the most important root causes. Now we are done with analyze. We have found the root causes, and let's move with the next step, which is improve, in which we need to move to selecting the solutions for these root causes and then taking action. And the improve, as I explained in the beginning, the objective of this process is to taking action, is to work with these root causes and find proposed solutions and select one of them and start implementation of these solutions. So in order to reach this point, we need to use some tools and techniques. And here we will use a tool called Solution Decision Matrix. And here we use it like that. We list each criteria or factor you need to consider when deciding the best overall solution. You know, let me explain to you. Let's come back here. We have here 3 factors, and we need to work on them. In order to finish this, or to get it done, or to work on these root causes, we need to take decision of which solution we need to select. And in order to choose which solution, you need to have more than one option, okay? So again, you will come back to the brainstorming and meeting with your team to find the proper solutions, you need to take actions. And here we assume that we have found, after having meeting and discussion with the team, okay, we found two options, option number A and option number B, okay. Fine. Option number A says that in order to solve these root causes, we need to set policies, processes, procedures for the machine calibration, and we will do it internally. We'll do it by ourselves. Number one. Number two, we will assign internal training system for the laborers. Number three, we will assign a development program to enhance the labor qualification. So we have three root causes, and we develop a solution from 3 points, each point attacking one root cause. This is option E. Option B, a part of the team suggests that we hire external body, okay, to monitor and control the machine performance. We hire external body to train the laborers, and we hire external body to enhance the labor qualifications. So, you know, like make or buy. We make it by ourselves or we buy it from outside. These are two options, and we need to select one of them. We cannot work with both of them. So we will use the solution matrix or solution design matrix to select the proper item. How can we use that? We write here the root causes: machine calibration, labor qualification, labor training. This is the root cause, and you write here the success factor. I mean, we have calibration problems. Okay, the we have here calibration problems. So the success factor here is to make proper calibration program. Yeah, clear. For the qualification, we have efficient performance for the laborers, and we have well-trained laborers. These are the success criteria. And you write here the importance of each root cause or the weight of each root cause. I mean, we have a problem of the rolling accuracy, and this is due to 3 root causes. What are the weight of each root cause on this problem? Okay, so rolling machine calibration 3, labor qualification 5, labor training 4. Okay, and based on that, you will move with the next step. You have solution A and you have solution B. So we have here option A and option B as solutions. And in each option, we will set the score. I mean, option number A, the solution number A, and option number A, which is here, set the process procedures for the machine calibration. It has weight of 3. You and your team in the brainstorming, you write this score based on the voting techniques, okay? Like that. I'll give you an example. You coordinate as Six Sigma or as leader for the project. By the way, you need to be a Six Sigma green belt, minimum green belt level to manage such projects. So you will decide with your team, okay, option number 1, what is the score? 1, 2, 3, 4, or 5, like from 1 to 5. Then you will collect the, you know, like someone will say 1, someone will say 4, and you will take the majority of these choices, and then you write here. So you write here 3, let's say for this option 3, 5, 5 for option number, solution number 1, solution number 2, and number 3. And in the same criteria in option number 2 here, or number B, you will say here, hiring external body, what is the weight? 4. Hiring external body to train the laborers, 3, and so on. And then here you will get the weighted score. You will multiply the weight element of this root cause by the weight or the score of this solution. And then you have here For each root cause, you have scale, and then you will make accumulation for the three options. And then you will decide based on the higher number. Here we have 54 for option number A and 35 for option number B. So we decide to select option number A. Fine. Then we will move with this action plan. This is the point. Then you will move down with the meeting conclusion. We agreed that we will move with solution number 1 or option number, solution option number A, which is 1, 2, 3. And then we need to calculate the ROI, and ROI, return on investment. We need here to estimate the cost to implement these actions and what is the ROI. And actually you need to have ROI above than 100, like 100 something, or percent, or 1 point something, in order to say you have a good plan or good project. Okay, here you are explaining the ROI, meaning, fine, in order to calculate the ROI equal to profit over the investment cost multiplied by 100%. So first you calculate the profit, and the profit here means we have, okay, what is a profit in terms of money? It means you calculate the current defect and you calculate the new defects, the reduced elements, and the difference will be converted to money. Let's say the paper cost, one paper cup is 3 EGB, okay? So you are losing this amount, 445, and then you will be losing 213. So the difference is 332 saved amount. Save the quantity of money. So this is the profit actually. So we write here, this is the profit. And then you need to calculate the investment cost. So in order to implement option A, you need to make some procedures, training, and then you write here the unit quantity, the unit cost, and the total cost per month and total cost per year. So you have this amount. So here, this is the investment cost. ROI equal to the profit over the investment cost. So it will be 129, which is fine. 129, or you can say it's 1.29. So ROI is, above 100%. So you are okay. You start implementing the work. It's a project now, okay? So you set the project objective. We need to enhance sigma level from, I think this is not right. It's, you make it, I think 3.3 to 3.6, something like that. I don't remember the amount. And then you write the project description and the objective, project schedule, project budget, okay? And project budget here is equal to 180,000, and you start the project execution. Means you set the scheduling for the training, you start calibrating the machine on a regular basis, you start enhancing the qualification of the laborers by making mentoring and the shadowing. You implement a real project to achieve the result. Then we move to the last process, and the last process here is the control. And in the control, you just sustain the result and make sure you are achieving the target. And what you need to do is you're making like progress sheet or control sheet, and you write here the 3 elements that you are working on, the actual, you put the actual and the plan, and you write, for example, we need to make policies and procedures here. You need to set 2, but you achieved 1. In Feb, you need to achieve 1, and you achieved already 1, and so on. And at the end, you make a collection, or as if you are collecting data. I added here, like some data to explain to you from my mind, but here you need to collect it in the real way, okay? And then you write here the summary, number of defects. It was before 148, and the target 190, yeah, and we achieved 77. DPMO, you write the before, after, or before target and after, you know, like you need to say, this is what we wish to have, or this is what we have already in the past, and this is the target, and this is the actual after finishing the project, and so on. And then you said here the target before we have 3.36 as current level. We wish to reach 3.67, but we reached already 3.64. Okay, based on where? Based on the number of defected item here you collected, and the actual controlling progress or reports. You collect data, and you said the new DPMO, it should be 15,000, but we couldn't achieve 15,000. We achieved only 16,000 something. And based on this 16,000 something, we have this 6 sigma, or this level of sigma. And then you said like that, this is the past, and this is the target, and this is the actual, you know, like that. You have another table for the DPMO, another table for the sigma level. Fine. Right now, you finished the project of the Six Sigma implementation on the documentation, and also you can apply the same exact template on the real flow. Okay. I thank you. I wish I could added a real value for you in this webinar. I tried to make it short, but I couldn't. I'm sorry. I'm ready to give you this Excel sheet. Please contact me to share it with you. Please send me your feedback. Send me your comments, and I will help you to give you more data. Please subscribe to my channel and like if you get value of this video. Thank you. I'm preparing more videos like that, so please push me, and I hope I can add real value to you. Thank you, and bye-bye.